My name is Niklas SCHMIDT. I'm employee at the Chair of Development and Assembly of Textile Products of the Technical University Dresden. I just want to talk about face masks. Is usually not the classical kind of clothing textile, but we also deal with that kind of textile. Apart from just shielding the wearer against viruses and bacteria, they have also other use cases, like it's quite important that the fit between face and face mask is quite good. On the other hand, we also face one challenge we usually face in textile product development, and that is we have a broad variation of body measurements within the population. In this set, the face usually changes, or the facial geometry change during speaking and similar actions. And this has to be taken into account as well for good mask design. We are able to measure facial features and facial measurements and take them into account for the development of parametric sewing patterns to one mask that is then, in the best case, a good or has a good fit with the face that was measured before. About what different kind of mask fit indicators actually exist. We can see gaps between the mask parameter and the face, or another indicator is the buckling of the mask, especially when the mask is too large for the face. Third, it's possible that the face is deformed by the mask due to the high mask pressure, which then occurs when the mask is too small. The last indicator for especially a poor mask fit under dynamic conditions like speaking is if the mask shifts due to the face movement. Possibility to check the mask fit would be the virtual donning. That includes the scanning of the mask and the scanning of the face. Testing method is or includes the fit simulation in a textile product development environment like vStitcher or Close 3D. And that's how we come now to use scanning as a mask fit evaluation method, because with scanning we are clearly able to include real wearing trials without modeling the stiffness or softness of the face, without modeling the elasticity of the mask. How can we apply our existing scanning technology at our chair in order to do such kind of investigation? We had one test person volunteering. We had a standardized mask. We have the 3D handheld scanner Leo by Arctic at our disposal at the chair. For the 4D scanning, we used the Move 4D scanning system by IBV. We had the test person scanned one time with closed mouth and one time with fully opened mouth. And both of these scenarios, one time with mask and one time without mask. So after capturing these 4 scans, we just aligned the scans, just to have a better visualization on what was going on there. We put a cutting plane at the nose-chin level, and this is then what we ended up with. And we also marked the mask edges because this made it easier to recognize. A word about the 4D scanning approach. We could just have the test person open the mouth and close it again, and one time without mask and one time with mask. That the alignment of the frames was quite easy. However, on the other side, as for the alignment of the frames without mask and with mask in order to determine the gaps, that was more difficult. We cannot make sure that the position of the person within the scanning space is in both scenarios exactly the same. And this was just a qualitative study, especially for the case of the gap evaluation. This 3D scanning approach was significantly better than the 4D scanning approach, which comes basically down to that the resolution of the applied 3D scanner was just much better than the resolution of the 4D scanner. And as for the mask shift evaluation, we can see that both scans basically show a clear view of how the mask shifted, and that our or the applied 3D scanning approach was best suited for the gap evaluation due to the higher resolution, and the applied 4D scanning approach was best suited for the mask shift evaluation because the lower resolution was not that decisive here,